Assalamualaikum and selamat sejahtera semua. So today we will learn about arithmetic and logic operation. Okay, so let's look at the AVR instructions first before we go to arithmetic and logic operation instructions. Right, so AVR instruction can be divided into four broad classes, which is a data memory and memory access. And then you have the data processing, which is you want to process the data. Either you want to add a subtract or multiply, or you can do the logical function, do the data shifting, and then we have a flow control, how we want to control the programming, either it is from top to bottom or from top to bottom, so you go back to the top and etc. And then a system control. Okay, without further ado, let's look at the data movement and memory access instructions. There are few instructions that already covered in the previous slide or in the previous class, right? So we have here, if you can see here, there are few data movement. They are from your general purpose register, which is your GPR, to IO space, which is your IO register. To move a data from general register to your IO space, you can use the in and out instruction, in which if you want to read the data from IO space, you use the in, while if you want to send the data out from general register to IO register, you can use the out instruction. Okay, and then if you have an immediate value, you can use the LDI, in which this constant number you load to your general register. And then we have the general register to move data from general register to flash. We use the LPM. Okay, LPM stand for load from program memory. And then if you want to move a data from your GPR to your RAM or extended IO, we can use the LD, LDD, and LDS. Or if you want to store data from GPR to RAM, you can use the SD, SDD, and SDS. Then if you want to, the other movement is between a register to with a register, you can use the MOV or MOVW, which is a MOV to copy a data from one register to another register. Okay, and then last but not least is if you want to move a data from general purpose register, your GPR, to your stack, we can use the push and pop instruction. Alright, so let's look at the MOV or copier. The first instruction here is MOV, which is you want to copy a register. Alright, so this instruction used to copy data on your GPR register. Okay, you can move from one register to another register by using the MOV instructions. Okay, if you see here, this is the syntax MOV RTRR, and your operands here, your register destination is bit either 0 from R0 to R31, and your RR, your source register also can be either from R0 to R31. So if you see here, this is the operation. Alright, so any value from RR you copy to your RT, and then the value of RR remains. Okay, and then you see for the data movement or memory access instruction, no flag are affected in your status register. Okay, then we have the MOVW. So what is MOVW do? You want to copy a register word. What is a register word? Means that you want to copy 16-bit data or 1 byte data. Oh, sorry, 2 byte data. Okay, so MOVW instruction is used to copy one register pair into another register pair. So you see here, this is the syntax. You use the MOVW, in which you want to copy 16-bit data from a certain register to another 16-bit data from to another register. So this is operation you see here, RR plus 1, RR, and then you copy this value to your RT plus 1 to RT. So this is your destination register, while this is your what we call source register. Okay, for example, here you can see you want to copy a content from R1 to R0 to R17 to R16. So you can use the MOVW R17, R16. So this is your destination register that you want to copy the data to. and this is R1, R0. This is your source register where you want to copy the data from. Right, so again, you see down here there are no flag affected for the data movement instruction. And then we have an LDI. So this one we already learned in the previous slide, so I might skip this one. Right, then we have the LDS, load direct from data space. So this one here, you used to load a 1 byte data from data space to a register. Alright, so this one, so we already learned in the previous class. So you see here, every data movement, any instruction that involve the data movement, the status register, your flag in the status register are not affected. And then we have the LT, okay, so load indirect from data space to a register. So this is we already learned. So this one in the pointer register data movement. All right, the previous class. Okay, you can see the previous lectures, or if you can see the previous notes. Okay, refer to the previous note. And then we have one, you can load the data from your, for example, your data space or the immediate value to your register. You can also store that value to another memory address. Right, so you can use the STS, store direct to data space. This one also we covered. And then we have the ST, store indirect from register to data space. Okay, so this one here you can see you have the post increment and pre-decrement. Okay, by using the pointer register. And then again, this one also we already covered. We have the in. Okay, this is a special instruction. If you want to move the data from your GPR to your IO register, we can use the in and out instruction. So in means that you want to load an IO location to a register. So this is an instruction here. And while out means that you want to store a data from register to your IO space. You can use the out instruction. Again, this one also I already covered in the previous slides or in the previous class. Okay, so if you see down here, okay, at the status register, none of the flags are affected because this is a data move. Okay, so now we continue with data processing instructions. So let's look at the instruction that involve in data processing. Okay, there are 4 data process to process a data. First, we call it as an arithmetic operation. This arithmetic operation is an operation that you want to do as addition, subtraction, multiplication, division, and etc. Then we have a logical function. This logical function you already learned in your digital electronic, in which you want to do the logical or, logical and, exclusive or, not, NAND, and etc. And then we also can do the data shifting, in which you want to shift the data to the right or to the left. Okay, and then we have the bit operations. So all of this process here can be is used for the data processing. Okay, let's look at the arithmetic operation first, and after that we go to the logical function, shift, and etc. Alright, so the first instruction for data processing in the arithmetic operation is ADD. So ADD stands for add data without a carry. So this ADD instruction is used to add 2 registers without the C flag and place the result in the destination register. Right, so you see here, this is the syntax. You want to add between these 2 registers. RD is your destination register, RR is your source register. So your RD and RR can be from R0 to R31. And this is the operation. What happens is you want to add the value from RD plus with RR, value from RR, and then after that you put the result to your RD. Okay, so if you can see here, down here, right, so this is your status register. There are 6 flags affected for the at ADD instruction, which are H flag, S flag, V, and Z, and C flags. Right, so let's look at the example here. Okay, so you are going to show the status of the C, H, and Z flag after the addition of 38 and 2F in the following instruction. Okay, so let's look at this instruction. So you have LDI R16 0838, LDI R17 0x2F. What happened here? You put this 38 to R16 and 2F to your R17. Okay, after that you have the ADD R16 and R17. What happened here? You want to add value from R16, which is 38, plus with the value from R17, which is 2F, and the result you put to your R16. Okay, so now after the ADD instruction, you are going to check what are the status of your C, H, and Z flag. How to do that? Right, so to do that, first you're going to what we call to convert this hexa number 3, 8, and 2F to binary number. Alright, so every time you see, every time you want to check the status register flag, so you're going to convert the hexadecimal number to binary number first. Right, so 3, 8, if you convert to binary, you get the 0, 0, 1, 1, 1, 0, 0, 0. Okay, you can use the calculator or to convert the number, or you can simply use the 8421 method. Right, and then 2F. What is 2F? After you convert this 2F to binary, you get 0, 0, 1, 0. F is 15 in decimal, which is 1, 1, 1, and 1. Okay, then what happened here is you add this number, right? So 0 plus 1, you get 1, 0 plus 1, 1, 0 plus 1, 1. 1 plus 1, you get 0, and then you have a carry here, alright, from bit 3 to bit 4. Okay, since you have carry here from bit 3 to bit 4, that's why your hash now become 1. Alright, your hash flag become 1. Right, so you 1 plus 1, you get 0. 1 plus 1 plus 1, you get 1. 1, 1 here, plus 0, you get 1, and 0 plus 0 plus 0. Okay, what about C and Z flag? Since there are no carry flag from bit 7, alright, there are no carry flag from this bit 7. So what happened here? So C equal to 0. And while Z, what is your Z? So your Z here, since you have a value, every time you have a value here, after you do the operation, addition operation or any instruction, you see you have a value, means that your Z equal to 0, because the R16 has a value other than 0 after the addition process or any other process. Alright, so what is the current value of your R16 after you do all the addition, and this is the value here. Alright, so you convert back this value 0, 1, 1, 0, 0, 1, 1, 1 to hexadecimal. Then your R16 now have new value, which is 16.7. Okay, let's look at another example here. Alright, you're going to same with the previous slide. You want to show the status of C, H, and Z flag after the addition of 9C and 64 in the following instruction. Okay, again, you have this value here, you put to R20, and then 64 you put to R21, and then you do the ADD R20, R21. So what you're going to do now is, what happens after you execute the instruction is, you want to add value from R20, add with R21, and put the result to your R20. Alright, so since now you are going to see what are the status of C, H, and Z flag, so what you're going to do here now is you need to convert this value to binary number. Once you convert this value to binary number, then you can determine what are your C, H, and Z flags. Right, So this is the binary number after you do the conversion, right? So 0 plus 0 you get 0, 0 plus 0 you get 0, 1 plus 1 you get 0, and 1 you have here, 1 plus 1 you get 0, and you have a carry from bit 3 to bit 4. Okay, so that's why your hash be equal to 1. Alright, next 1 plus 1 you get 0, you have a carry. 1 plus 0 plus 1 you get 0, 1 plus 0 plus 1 you get 0, 1 plus 1 plus 0 you get 0, and now you have a carry flag beyond your bit 7. Now that's why your C equal to 1. And last but not least, what about your Z flag? Okay, since your Z flag, your after the addition, the value of R20 is 0, then your Z flag equal to 1. Okay, for the next instruction is ADDC. ADDC stands for add with carry. So this instruction used to add 2 registers and the content of the C flag and place the result in the destination register. So if you can see here, this is the syntax of ADDC. You have a ADDC, RD, and RR. Again, your RD and RR can be from R0 to R31. But here, in this addition, you need to involve the carry. Alright, so this is your carry. RD plus RR plus C, and put the result to your RD, in which your C flag is coming from your status register, the current value of your C flag inside of your current register. Alright, let's look at the examples here. So you are going to write a program to add 2 16-bit numbers. The numbers are 3CE7 and 3B8D. Assume that the R1 already have 8D, R2 3B, R3 E7, and R4 3C. So you're going to place the sum in R3 and R4. So R3 should have the lower byte. So how are you going to do this? Right, to do this, first, okay, we need to know what are the 16-bit numbers. Alright, so now you are going to add this number here, 3C7 plus with 3B8D. Alright, so plus with 3B8D. Alright, since this is a 16-bit number, so you are going to divide it into the low byte and high byte. So you divided this to 2 sections. Alright, 2 columns. One is stand for low byte and the other one is high byte. Alright, so in this question, it already saying that your R1 already have 8D. So this guy here, you already place in R1, and R2 3B. Alright, so sorry, this is a 3B. Right, so this is your R2, and then you have the R3 is E7, so this already inside R3, and R4 is 3C. Okay, next. And then what are the identification that we can obtain from this question is, you are going to place the sum in R3 and R4, and it says that R3 should have the lower byte. Okay, so the result from this addition here, you're going to put to your R3 and R4, in which R3 is your lower byte. So now you are going to write a program. Alright, so usually on the lower byte here, okay, to add these 2 numbers E7 with 8D, you can use the ADD instruction. Okay, while for the high byte here, to add a 3C plus 3B, you're going to use the ADC. Why ADC? Why cannot ADD? Because sometimes after you add the low byte, you might have carry here. Alright, so you need to consider this carry to add for the high byte. So that's why we use the ADC. Alright, so how to write the program here? Alright, since this value 3C E7 3B8D already inside the register, so you don't need to load this value to this particular register. So what you're going to use is you just write down the ADD. Okay, we need to add the low byte first, and then after that we follow with the high byte. So ADD R3 with R1. Why R3 R1 not R1 R3? Because you're going to store the result inside of your R3. That's why we write our program here ADD R3 R1. Okay, next. The next instruction that you're going to use is ADC, in which you want to add the high byte. So you use the ADC R4 with R2. Right? So that's it. This is for the what we call to add the 60-bit number according to this example here. Right, next we have the ADIW. So what this ADIW do is you want to add immediate value to a word. Right, so going to write add immediate value to a word. Right, so you see here, alright, so this instruction used to add an immediate value which is from 0 to 63 in decimal to a register pair and place the result in that register pair. Alright, so this is the syntax. You see here ADIW RD plus 1 column RD comma with K, in which your RD, okay, you need to use from R24, R26, R28 and R30 only. Right, so, because this is a register pair. If you use the R24, then its pair is R25, because RD plus 1, R24 plus 1, you get the R25. Okay, what about your K? Okay, since here this is ADIW, your K is between 0 to 63 only, cannot more than that. Right, so this is the operation RD plus 1 RD, okay, plus with K, the immediate value that you're going to add, and then put the result to your that RD plus 1 RD. Okay, so this is example here. Right, so okay, let's look at this example. Okay, you have the LDLZL13 LDIZ shift 53 and then ADIW R31 R3026. What happened here? Okay, you want to add this number here with the immediate value of 26. Okay, that is for the ADIW. Right, next we have the SUBI. SUBI stand for subtract without a carry. Okay, so this SUBI instruction used to subtract to register and place the result in the destination register RD. Alright, so the syntax is SUBI RD RR, in which Alright, you see the operand for RD and RR can be from R0 to R31, and the operation here RD minus RR, and put the result to RD. Right. Let's look at this example here. Okay, show the step involved in the following. Alright, so the first line here, LDI R20 0x23. What happened here? So you were going to put 23 to R20, and then LDI R21 0x3F. What happened here? You're going to load 3F to R21 and sub R21 R20. So you're going to subtract R21. What is the value R21? Is 3F minus with R20, which is 23, and put the result to your R21. Okay, so 3F minus 23, and the result is 1C. This 1C now you store to your R21. Right, then we have the SUBI, so subtract immediate. So this instruction used to subtract a register with a constant value and place the result in the destination register. Right, since this is, you see here, SUBI, every time any instruction that ended with the I, so the RD here you need to use the register between R16 to R31 only, because it involves the immediate value. What about your K from 0 to 255? Alright, so operation, what about the operation? RD minus K, put the result to your RD. Alright, so what about the flag affected? Okay, so this is the flag affected here. Alright, okay, you can see every time you do the data processing, the flag will be affected according to that instruction. Right, next, let's do an example here. You are going to write a program to subtract 18 from 29 and store the result in R21. A, without using the SUBI instruction, and B, by using the SUBI instruction. So how are you going to do that? Alright, so to do that, okay, first, what you're going to do here? Okay, you want to subtract 29 with 18, and then put the result to R21 or something like this. Okay, you can write down something like this: 29 minus 50, and put the result to R21. Okay, A, without using the SUBI instruction. So how are you going to do that? Okay, first, okay, this 29 and 18, is it inside of your register? Not yet. So when this number here not yet inside of your register, what you're going to do is you need to load this number here to your GPR. Okay, because if you recall back the SUB, what the SUB instruction, then what is the syntax of the SUB? SUB says that SUB must be followed with RD and RR between two registers. You cannot simply what we call subtract immediate value with immediate value and put to R31. So what you're going to do here, since you are going to store the result to R31, so make sure that this value here you need to put to R21. What about the second value here? Okay, the second value you can put in any of the GPR. Okay, you can use the R16 for example. Alright, so what you're going to do now is load R21 with 0 to 9, and then load R16 with 0818 and do the SUBI R21 R16. Okay, this is without using the SUBI instruction. What about if you're going to use the SUBI instruction? How to do that? Okay, to do that, okay, it's similar here. Okay, so make sure that, alright, so the first number here you're going to put to your R21, but the second number here now become your immediate value. Okay, immediate value. So how to do that? Okay, so this one here, the first value here, you're going to put, or you're going to load to R21. Why? Because at the end you going to use the R21 to store the result. So LDI R21 with what value? 0829, and then now you can use the SUBI. Okay, subtract immediate R21 with what value? With this value 0818. So that's it. Only 2 line of instruction compared to this one here. You going need to use 3 line of instruction to do the same operation. Right, next we have the SBIW. Okay, so SBIW subtract immediate from word. Okay, similar to ADIW. So this one here used to subtract an immediate value which is only from range 0 to 63, cannot more than that, from a register pair, and place the result in the register pair. Right, so this is the operation syntax. SBIW RT plus 1 RT, comma with K. Your D should be, you are required to use the D from R24, 26, 28 and R30 only. What about your K? Your K must be between 0 to 63. Okay, no more than that. Okay, so this is the operation. RT plus R1, column RT, minus with K, put the result back to your RT plus 1 top RT. Okay, let's look at this example. Alright, you're going to write a program to subtract 18 from 2917. Okay, so how to do that? Okay, write a program to subtract 18 from 2917 and store the result in R25 and R24. Okay, so again, okay, so you need to know what okay, so you're going to subtract 18 from 2917 and store the result to R25 and R24. Right, so now we're going to write the program. Before we write the program, make sure that okay, you write down the equation first, and then you know what you're going to do. Okay, so this is what the question wants, right? 2917 minus with 18, and then you want to put the result to R25 and R24. Since the first value here is 16-bit number, so you need to divide the low byte and high byte. So this is a low byte and high byte. So this is R24. Okay, and then place the result of the subtraction to R24 and R25, in which R24 is your lower byte while R25 is your higher byte. Okay, next what you're going to do is, right, so this one here, okay, there are a few solutions to answer this question here. Okay, the first one, right, we can use the SUB and SBC, right? SUB and SBC. How you're going to do that is, right, so first this one here, since this is a low byte, you need to use the SUB without a carry. But for this one here, you're going to use the SBC. Why SBC? If you see here, this is 17 minus with 18. 17 is smaller than 18. Then you need to borrow from here. So that borrowing process will produce the carry. So that's why we use the SBC at our higher byte. Always use the SBC at our higher byte for this kind of operation. Right, so how to write a program? So first thing first, make sure that this value here you put inside your GPR, because this value is yet inside your GPR, so you need to load to your GPR first. So this one here, since this one you're going to store, okay, the subtraction, the result of the subtraction you're going to store inside R24, R25. So why not we put these values 17 to R24, this one to R25, and this one here you can put to any. So this is R26. And what about this one here? Okay, this fellow here we can put a 0, 0. So this is R27, for example. Right? So right now the, okay, this is the first solution. Okay, load I R24 with OX17, load I R25 with OX29, load I R26 with 0818, and load I R27 with 0. Okay, then you can use the SUB. Okay, so SUB R24 minus with R26, and SBC R25 minus with R27. Okay, this is the first solution. Okay, the second solution here, you can use the SBIW. Right, so SBIW. Okay, since this is 18, alright, since, okay, the B here we're going to use the SBIW. For the SBIW, it says that the K, okay, the second value here must less or equal than, 63. Okay, so you convert this 18 to decimal, and after that you know that, oh, this value here less than 63, right? So we can use this SBIW. For if this number here is greater than 63, then you cannot use the SBIW. So how to do that? Okay, first thing first, right? Again, since this one here you're going to place the result to R24, R25, okay, make sure that this value 17 and 29 you load to R24 and R25. Okay, load R24 O at 17, load I R25 OX29, and then after that we use the SBIW. SBIW. Alright, R25, R24, and then what is the value of K? K is 10818. Okay, so by comparing the first solution and second solution, you see the second solution has less instruction, only use 3 lines of instruction, but for this one you're going to use the 6 line of instruction, but the answer is still same. Right, next we have SBC. Oh, this one I going to tell you the SBC. What is SBC? SBC is subtract with carry. All right. So the subtract is carry is used to subtract two register and subtract with the C flag and paste the result into the destination register RD. So this is the syntax SBC RD RR. Okay, your RD and RR can be from R0 to R31. What about the operation? So the operation here is RD minus RR minus with C. So this C flag here is any value from your status register, is either 0 or 1, and put the result back to your RD. Okay, let's do an example here. Okay, you are going to write a program to subtract 60-bit number, okay, which is 2762 minus with 1296. Assume that R26 already have 62 and R27 have 27, and place the difference in R26 and R27. Okay, so from this question here, you know that you're going to subtract two 60-bit number, which is 27 R2 minus with 1296. Alright, this is the first what we call first information that you get from this question. And then the second information is telling you that assume that R26 already have 62. So this value here already inside R26, and this value here already inside R27. And then what is another information that you can get here is place the difference in R26 and R27, which is R26 should be the low byte. Alright, so since this is a 60-bit number, you can divide this to 2 bytes. One is low, the other one is high. Alright, so the value of this instruction here this subtraction go to R26, while this one go to R27. So now you're going to write a program. So how to write a program? Since this one here, okay, you already divided to the low byte and high byte. So always for the low byte, we can use the SUB instruction. What about the high byte? High byte, we need to use the SBC. Why SBC? Why cannot SUB? Because sometimes, okay, if you subtract small number with the high number, such as this one here, you need to borrow from the left, okay, which is your high byte. So that's why the high byte always use the SBC. Okay, since 62 and 27 already inside R27 R26, so now you are going to load these two number here to any register from R60 to R31, which is for this one, let's say we use R16, then this is R17. Okay, so load I R17 with OS12, load I R16 with OS96. Okay, next, what are you going to do? Okay, then we use the SUB. SUB, which register and which register? R26 with R16. Why R26 with R16? Because now you're going to subtract this number with this number and put the result to R26. So sub R26 R16, and then next SBC R27 with R17. Okay, and then we have the SBCI. So why is the SBCI? Subtract immediate with a carry. So used to subtract constant from a register and subtract it with the C flag and place the result in the destination register. Alright, so this is the sales there, SBCI RT with K. Since this instruction here ended with an I at the back, so your GPR here you need to use from R16 to R31. 31 only because it's involved the immediate value. What about your K? Your K can be from 0 to 255 in decimal or 0 to FF in hexadecimal. So this is the operation RD minus K minus with C, put the result to RD. Right.